Hello all, my name is Saurabh Ghosh. Today I'm gonna briefly discuss on graphene polymer composite for solar cell. So let's begin. Graphene. Where does this graphene comes from? Graphene graphene comes from carbon family. Graphene is one of the allotropes of carbon. It is the world's strongest material, even stronger than diamond. It is a 2D material, one atom thick. It is a sheet of carbon structure. It is a basic structure element of other allotropes, including graphite, charcoal, carbon nanotubes, and fullerenes. Um, it is like many stacked graphene sheets create graphite. Graphene is a wonderful metal. It has extraordinary thermal and electrical conductivity. It's thin, light, and flexible. It's transparent. Graphene structure is a 2D network of carbon atoms. These carbon atoms are bound within the plane by strong bonds into a honeycomb array comprised of six-membered rings. By stacking up these layers on top of each other, the well-known 3D graphite crystal is formed. It is a basic building for graphite materials of all other dimensions. So in short, graphene is nothing else, just a single graphite layer. So the next is graphene's properties. There are many properties of graphene. The major properties are number one is it's flexible, it is highly conductive, it is transparent, it has mechanical resistance, and the most unique property is it has zero energy gap. So before jumping on graphene's application on solar cell, let's just briefly give an overview on relationship of graphene with electricity. This material carries electricity more quickly, uh, more precisely, and more efficiently than any other known material. We must be thinking that copper is nothing is more highly conductive than copper, but in fact it's not true. Uh, in today's era, graphene conducts electricity even much better than copper. The reason why this is the reason is that graphene. This is the reason that graphene conducts electricity so well. So that because electron can move fantastically fast. This gives graphene limitless application, including conductive paint, high frequency devices, and more efficient batteries. As for its intrinsic mobility, it's much better than silicon. Thus, electrons have no resistance when they move through graphene. As a result, people can potentially use graphene to produce batteries that will have 10 times the electrical retention capacity of anything that we have. So, in future, so there might in future is the automobile batteries. Graphene will be recharged incredibly quickly. So in future, in graphene automobile batteries, just a 5 minutes of recharge of graphene batteries will make that automobile run more than 2 days. So it's pretty much impressive case. And one more quality of graphene is that it expands when it's cooled and shrinks when it gets warm, unlike other material where materials get shrink when it is cooled and gets expand when it is heated. But in graphene it's completely different property. It has completely different property. It will be possible to for graphene to go from empty to full just 15 minutes of recharge. Moreover, graphene can be recharged more than 3,500 times. That's fascinating. So now comes the solar cells. So graphene turned out to be a promising material for photo electrochemical energy conversion in dye-sensitized solar cells. The transparent, conductive, and ultra-thin graphene films are fabricated from exfoliated graphene oxide, followed by thermal reduction. The obtained films exhibit a high conductivity of 550 seconds s per centimeter and a transparency of more than 70% over 1000 to 3000 nanometer. The elements of solar cells. There are different elements of solar cells, which are absorber, emitter, electrodes, and anti-reflecting coating. Anti-reflecting. The graphene's used in solar cells. Graphene is optically transparent. This makes it extremely interesting material for scientists, as there are many materials which are highly conductive but are not transparent as graphene. So this unique property of graphene makes its lens application on photovoltaic cells. At present, there are several different variations of graphene cells which are being researched. There are there are three main areas where graphene is helping solar panels. Mm, Electrode. Uh, Number two is photovoltaic cells, photovoltaic materials, and the third is charge holder. So let's proceed one by one and discuss those and this solar panels. Electrode. Graphene has higher electrical conductivity. It has low resistance value of 3.1 microns per centimeter square. It has an impressively low resistance value. This sounds even more astonishing that when we consider that graphene is a 2D material. If we look at a ordinary solar PV cell, then we find metal strips covering it. These strips or mesh wires are there to collect the free electron ejected by the sun rays. There are two disadvantages of having these strips. Firstly, they do not cover all the areas for collecting the electrons. And there is a reason for that, which is in fact the second problem. The rays of sun are blocked by these metal strips or on areas covered by them. This mesh of conducting strip sits right at the top and can block up to 5% of sun rays reaching the PV cell. This is where graphene fits, and this is where the graphene plays an potential role. So which reduces and this is exactly where graphene is used. It is transparent and it can collect electron not ejected by the sun rays, thus improving the overall efficiency of the panel. Also, the layer of the graphene is flexible, and thus this ideal for organic solar cells whose unique selling point is their flexibility. Graphene is also an indispensable material for panels that require flexibility as well as transparency. At present, indium tin oxide is used in solar panels, but although this material is conductive and transparent, but it is stiff and brittle. So that's the disadvantage of using indium tin oxide. It can crack up when cell is flexed, and therefore graphene is ideal. It has to be further noted that indium tin oxide is expensive, as only 5 gram of it as only 5 gram of indium tin oxide cost hefty price. So it can also damage to the organic layer and thus the oxide layers, which is very sensitive to wear. On the other hand, the bending with the graphene is more natural and smooth. In short, graphene can not only be used to improve ordinary silicon solar cells as an electrode, but also can be used for transparent and flexible solar cells. So that's a good use of graphene as an electrode. Another use of graphene is PV material. Almost solar cells are based on the combination of P and N type semiconductor material. There is a new breed of PV cells emerging that are based on Schottky junction diodes. This is an attempt to increase the efficiency of solar cells by using slightly different process than PN type solar cells and adding an impurity energy level in the band gap through the use of new materials. And one of these new materials is doped graphene. It has been reported that graphene silicon Schottky cells have reached efficiency of 10.69%, where graphene perovskite cells have surpassed efficiency of 20.3% in lab test. So finally, let's now examine another use of graphene in solar cells as a charge collector, or we can say charge holder. The third main area of research for graphene and PV is its use as a charge holding parallel plate, just like a thin capacitor. Scientists from University of China have been working on harnessing the power of rain through solar panels. As we all understand, rainwater is not pure and it has positively charged ions of sodium, calcium, and ammonia. So, a layer of graphene is placed on the top of solar cells not as a current collector but as an iron holder and a separator. The solar panel is sandwiched between the layer of graphene at the top and indium tin oxide and plastic at the bottom. The positively charged ions bind to the ultra thin layer of graphene, forming a double layer, technically referred to as a pseudo capacitor with the electron already present. The potential energy difference between the two layers is strong enough to generate electric current. Uh, so this is why graphene is used, but till now graphene has not been used as a main source. In future, graphene has a high potential. It will generate huge profit if graphene obviously definitely graphene would come in market, but it till now it hasn't come to the market. So the scientists are researching on graphene quite generous. So let's look at the advantages of graphene solar cells. Uh, it has high efficiency energy. It's eco-friendly. I feel it's eco-friendly. Uh, it has longer lifespan and can be easily replaced. Uh, and the panels of graphene solar cells is flexible. The applications of graphene solar cells. Uh, Coating existing roofing materials with 3D graphene cells, then enough energy could be captured to power almost the entire house. 3D graphene solar cells would also help provide electricity for rural areas or third world countries. Have flexible layers of nanoporous germanium and graphene of 3D structure to produce lightweight solar cells for mobile applications. So, the conclusion is solar power is looking more and more attractive as other power generation methods such as fossil fuels and nuclear power come under increasing scrutiny. Nanomaterials solar cells show special promise to both enhance efficiency of solar energy conversion and also reduce the manufacturing cost. It increases efficiency by increasing the absorption of light as well as the overall radiation to electricity, would help preserve the environment, decrease wastage, provide electricity for rural areas, and have a wide area of commercial applications due to its capabilities. So with this, I would like to conclude here. Thank you.